C2, integration, example 7. So here we are given the diagram of the line of y equals x times 4 minus x and the line y equals x, and we're asked to find the region bounded by the curve and the line. So that is this region here. So I'm just going to say that, well, y equals x times 4 minus x is just the same as 4x minus x squared. So I'm going to be integrating between 0 and 3 for this first method, which is subtracting the equations. I'm going to be integrating between 0 and 3 the equation of 4x minus x squared minus x, because that's the line with respect to x. So that equals the integration between 0 and 3 of 3x minus x squared dx. And when I integrate that, if I add 1 to the power, that's x squared, and divide by the new power, so that gives me 3 over 2 x squared minus, add 1 to the power, x cubed, divide by the new power, so that gives me x cubed over 3, and I am evaluating that between 3 and 0. So when I substitute 3 into this, I have, well, 3 squared is 9. 9 times 3 is 27. So I have 27 over 2. Minus, when I substitute 3 in here, I get 27 over 3, which is just 9. And then if I evaluate it at 0, I just end up with 0 minus 0. So this is the same as having 27 over 2 minus 18 over 2. And of course, 27 minus 18 is just 9, so I am left with an area of 9 over 2. So that method is subtracting the equations of both of the lines. But now we could find the area under first the curve, so the area here, and then subtract the area under the line, so that we're left with just the region that we found by subtracting the equations. So, to find the area under curve, we're integrating between 0 and 3. The equation of 4x minus x squared dx. So if I add 1 to the power, that gives me x squared, divide by the new power, so that's just 2x squared, minus, add 1 to the power gives me x cubed over 3. And I'm evaluating that between 3 and 0. So that gives me, if I put 3 into this, I get 3 squared, which is 9. 9 times 2 is 18. Minus 3 to the power of 3 is 27. 27 over 3 is 9. And of course, when I substitute 0 in, I just get 0 minus 0, which just leaves me with an area of 9. So now I need to look at the area under the line y equals x. So I'm integrating between 0 and 3, just x. So that gives me x squared over 2 between 3 and 0. And when I substitute 3 into this, I get 9 over 2. And when I substitute 0 into this, I just get 0. So that just leaves me with 9 over 2. And to get my final answer, I'm doing 9 minus 9 over 2, which just leaves me with 9 over 2. So no matter which method you decide to use, you end up with the same area between the line y equals x and the curve y equals x lots of 4 minus x.